So far we have discussed the integer data type, double data type for numbers. We have also talked about the operations for the numbers. We have also discussed how to read the data from the keyboard and print data out to the screen. Now, I would like to discuss more about the numbers, including the mathematical methods. First, I would like to discuss the post and pre-increment and decrement operator. Right here, you can see this x plus plus. It can be read as x value before increment or x value before increased. The meaning of this operator is you read the data from the memory x and assign it to a y value, but this one actually there is no recipient for the output value. So actually, if the initial value of x is 0, the value changes to 1 after this increment operator. So the equivalent operation would be x being read out and assigned to certain value y if there is a y over here, but right here there's none. And then you increase x by 1 and assign this new x plus 1 value to the variable x. So x is effectively increased by 1. And right here, if you put a double plus sign before x, that would be you increase the number x first, and then you assign the value to the recipient variable y. But right here, there is no y over here. And we read this operator as increment before the value of x. Right here, I would like to introduce another group of the operators. We call it augmented assignment. Our regular assignment use the equal sign. So x equals 1 actually means we assign the value 1 to the variable x. And then we can read it as store 1 to the variable x. And if you see a plus sign and the equal sign, it is written like this. We have the x increased by 1. And it is equivalent to increase the value of x and then assign it to the variable x. So we read this statement as x increased by 1. Similarly, this one, we will read it as x decreased by 1. And this one is x multiplied by 1. And this one is x divided by 1. And this one is x tensor modulus by 1. And actually, you have the x tensor modulus by 1, the result can only be 0. We finished the discussion for the arithmetic operators. Now, I would like to discuss more about other operations that you can do in mathematics using Java language. So right here, we have an API that reads as Application Programming Interface. We have this math class. A math class is a collection of mathematical functions and constants. So over there are several methods, and methods is another name for functions. So for example, if we use this math.max 5 and 6, it will return the maximum value for 5 and 6. So the output will be 6. If we use this max.max 6.8, 5.4, it will return 6.8. So the same max function or method can accept integer input and double input and provide the return value in integer output format and double output format. And both of them share the same name max. We call it overloaded function. And we have this max function in double format, floating point format, integer format, and long formats. Several different formats. And in math class, we have a collection of mathematical constants and functions. And we have these different rounding methods. Ceilings is for the nearest integer that is larger than the current value x. And floor is the nearest integer that is smaller than current x floating point value. And round is using the standard definition of rounding operator in mathematics. And this one is different from the previous three because it will return the data in integer value, and the previous three will return in double value. And we have minimum, maximum function as the example before, and we have the absolute value function. We have random number generator that will generate a random number between 0 and 1, but not including 1. And we also have these different power and exponential functions, including exponential function, log function. This log function would be natural log. And then we have log 10 function, power function, and square root function. And to use these functions, you need to put the class name math. The method name, for example, exponential, you should do math.exp parentheses and your parameter x. That will return you the epsilon to the power x. And then in math class, we also have sine function, cosine function, tangent function, and these are in radians unit. And then you have the 2 radians, and taking the input from degree value, and you will convert it into radians. And also you can convert the radians into degrees. And there is also arc function for sine function, cosine function, and tangent function. We call it arc sine, arc cosine, and arc tangent. And this collection is the trigonometry functions. In the previous lecture, we talked about data input. We read in the data from console. In this program, we are going to work on the math functions. We have finished the arithmetic calculation and also to calculate the area for a rectangle. Now, let's try to calculate the area for a circle. To calculate the area for a circle, we need to have the value for radius as defined, as declare a variable r. Let's read in the radius from the console. Before we do that, we also need to ask for the input. Then we can declare a variable called area circle. To name a variable with 2 words, you can put the first one in lowercase, the second one with leading capital. Usually the class name is with the first letter in capital, and the variable with leading letter in lowercase. And then we need to have the value of pi. We can type in 3.1416 times r times r. That can calculate the area for radius. But if we want to have a value from the library, we don't want to use this number, we can use math.pi. Math is a class that is a collection of the mathematical functions and constants. So math.pi give you the pi value, and you put times r, this will be pi r squared. And to calculate the r squared, we can also use a math function called math.pow for power. And then r for radius, 2 for order 2. Now we'll also calculate the area for the circle. And then at the end, let's print out the circle area as well.
This will print out area of a circle of radius equals this is the area number. Let's compile it and run. Let's type 5, 3, 2.53, 6.24, and then radius, let's try 4. So radius equals 4. 4 times 4 is about 16 times 3 point something, that's about more than 48, so 50 is right.